All right, everybody, good evening. It's Tuesday again here, Dr. B, and we're going to do some chemistry this evening, and we're actually going to talk about a number of different things. So before we get started, though, I have this image up here. I have this red cat on an ox, and this is something I used. I think I used Google's their AI Bard. You can create images now. So if you can figure out what this means, drop that in the chat. And please say hello in the chat just so I know who's there. I see Loretta's here tonight. Who else? We have board exam, class 10. Nice. THV has a quiz tomorrow on balancing. We're going to balance an equation tonight, so hopefully that'll help you out with that. We kind of got to this interesting place now in the semester where we've been, doing classes for a bit. Things are starting to get kind of heavy. So, stay positive and don't let stress get on top of you. Things are starting to pile up. And one of the ways that you can really be effective in chemistry is to work lots of problems, especially if you work them with somebody. So make sure you're not just reading and memorizing. Work the problems, make mistakes, figure out what you did wrong. That's really how you end up improving in chemistry. And a lot of students don't do that. So I see we have Madhurija, if I'm saying it right, S. Burr, excellent. Taylor, whose exam went well. Awesome. Very nice. Decomposition reaction video. I'll try to talk about that later. So let's do this here. I have let's see if I can find it. Here we go. Yeah. We're going to do 10 questions, and we haven't done multiple choice questions so much. Tonight is multiple choice, and these are based kind of on that AP exam format. So they're challenging, but not terribly challenging. So has anyone figured out why there's a red cat sitting on an ox? One of the clues is that it says this is an ox. All right. So we'll talk about this later, but it does have to do with anodes and oxidations and reductions and cathodes. So we'll go back to our red cat on a blue ox. First question. Let's see if you can do this one. So this is pretty typical of an AP or maybe a JEE type question, where they give you the group and the period. So you have to find the element, and then you have to figure out the electron configuration. So take a moment and do that. First, see if you can figure out what element we're talking about, and then see if you can figure the configuration out. This is a great question. I like this one. All right, Jessica, cation. It's close to that. Cation's that T in cation. Someone told me the other day, positive. Like cat pause. Cations are positive. I don't know. All right. Cations are positive. That's terrible. All right, so let's see if we can find this element here. Which of the following describes the electron configuration? Ground state just means it's like these here on the periodic table. Group 15, so 1, 2, all the way up. I know that this is 13 because there's 10 here in the D block. 14, 15, so it's going to be here in this group, and periods go 1, 2, 3, 4. I always kind of think they go down like this. 4, so we're talking about arsenic, atomic number 33. So THB, you're saying the first one? I like your thinking. Why are you thinking that though? So we see that we have argon here. So if we went back, you'd see argon. That's why we have AR. So we know it's got to be this one or this one here. And it should all add up to 18 plus some number should give you 33. So they should all add up to that. But the easier way is to know that this is 1s1. Let's put this up here. These are all end in S2, P1, P2, P3. So it's got to end in P3. It's got to end in P3. And right there, P3. So it's got to be choice A. Let me take and move this down here so you can see it. So if you memorize that all these are S1, S2, P1, P2, P3, you can quickly figure out what that last term will be. And that helps you a lot on these problems. You can really get through them quick. All right, let's try another one. Is there another one here somewhere? I think there is. It's kind of interesting. There's not many people on tonight, which is surprising. I think part of it is maybe the date on the thumbnail for the stream was messed up. So I'm not sure if that's why or not, but we're going to just soldier on here. Which molecule has polar bonds but is not a polar molecule? Take a moment and look at that. And I do have the electronegativity values here to help you kind of look at that. So they all have some polar bonds to them. So what you're looking for is a big difference in electronegativity. Hey, Toasty. Yeah, you're chem major. Chem major, that's some tough business, especially when you get to PChem. So what you really have to understand here is that polarity, if you have a difference of, in this case, we have carbon and oxygen, so carbon here and oxygen, a difference greater than 0.5, but less than 2. You can see this is about 0.99. The bonds will be polar here, hydrogen and oxygen, everything's going to be polar. But let's take a look at the actual molecule here. So I'm going to open up a browser. And we're going to look at right here. This is our molecule. So what ends up happening with this molecule right here is we have a polar bond. The bond right here is polar, but overall these are pulling in the opposite direction, so it's symmetrical. And because of that, this is the one that's not polar. If we look at, say, water, right here, put our URL in, water isn't symmetrical. And so if you look at the surface of that water molecule there, you'll see that we have a positive and a negative side to it. There it is. So down here it's a little positive, up here it's negative. We have this electronegative oxygen. So that's kind of useful to know. So if we go back to our question, we kind of answered it already because we know that even though we have polar bonds here, they're pulling in the opposite direction. So that's going to be the correct answer right here. Yep, hey, you got it, Madhuria. All right, so that's pretty common to see this type of question on an exam where you have to figure out which bonds are polar and not polar. And then sometimes they try to trick you with the symmetrical molecule. So if that molecule is symmetrical, it's going to be nonpolar because the dipoles will cancel out. All right. They love boiling point questions as well on these exams. These are like favored questions. So which has the highest boiling point? And I'll pull over here. You can see these are all noble gases. You can see them all here. So which one has the highest boiling point? So which one is the lightest? Looks like neon's the lightest. And then argon, krypton, and krypton looks to be pretty heavy there. So if you look at the trend, new account, welcome new account. If you look at the trend, which one is the heaviest? That's our xenon D right here. And as we go down, you can see they're getting bigger. We're adding actually energy levels. Every time you go down a period, you add an energy level. And when they get a lot bigger like that, you end up having kind of temporary dipoles form around the atom called London forces that will kind of attract them. So they're more polarizable when they're bigger, so they stick together. They kind of cling to each other. So if you're thinking about them clinging to each other, do I have some data? I think I have some data here. If you're thinking about them clinging to each other, the ones that cling to each other, they're going to have, it's going to take more energy to boil, higher boiling points. And right there, xenon, even these are all negative, but this is the closest to zero. So this one right here is xenon. That is our answer. Highest boiling point is going to be xenon, and that's because it's bigger and it can form London, these intermolecular forces, the London forces. THV, you got it. Yeah, xenon, excellent. We have a few more people here. It's really quiet tonight. I think it's because I put the wrong date on that thumbnail. All right, someone was asking for balancing. Here is a balancing equation. See how quickly you can do this. This one actually isn't so bad now that I'm looking at it. So sometimes people will write like carbon, hydrogen, and oxygen on each side. This is how I teach it when I was starting out. Okay, THV, that was you. So some people will do this so they can just count everything up and keep track of it. For this one, it looks kind of straightforward because you have, I always do the carbons first here when we have these organic combustions. So 3 carbons. So we have 6 plus 1, we have 7 oxygens. Then the hydrogens, I have 8. So I'm just going to put a 4 here, and those are balanced. But now I have 6 plus 4 is 10. And always leave that oxygen last. Because now the oxygen's there. When we change this, won't change anything else. Put a 5 there. So that's pretty quick. I have on my community tab on my channel, I ask a quiz question. I ask a quiz question every day, and I ask how quickly can people balance different equations. And most people were saying around 5 or 10 seconds, which really impressed me because I'm not that quick myself. So we have some really, really fast balancers. But if you're careful, it doesn't matter how fast you go, you can get it right on an exam. Hello, L. Marks. Welcome. Welcome. Now we have some more people. It was kind of thin there for a while, but that's all right. Take a look at this one, some kinetic molecular theory here. These are kind of conceptual problems, and they like to put these conceptual problems where something is doubling and so on. All right. Hello, Herzifa. So we're increasing the temperature. And when we think about increasing the temperature of something, it's real good to try to visualize what happens. So this is, I'll put this app in the chat for you here too. I really like this one. And then let me just open it up. And if you use these when you're trying to solve problems to help reason them out, that's really going to help you. Hello, daily learning. I hope this is your daily learning we're doing here, right? So let's put a bunch of atoms in here. And when they're hitting the sides, that's what creates the pressure. So if we increase the temperature, they're going to hit the sides a whole lot more. And the pressure, you can watch, it just keeps going up. And eventually, hopefully it'll just blow the top off. There it goes. It just blows the top off the container. So if we go back and we look at that question, keep kind of this temperature and what you saw happened in mind. What happens? THV, you're asking if it's B? Yeah, it's those collisions. And so that's important because a big idea in chemistry is collision theory. Molecules have to collide to interact or to form bonds. If they don't collide, they won't ever form a chemical bond. They can't create pressure. So rate of reaction, more collisions, more reaction. So that's a pretty common one. We'll see that quite frequently. All right. This is a kind of a good one. They're trying to get you to use the vocabulary here, the concept, and then apply it to different situations. So take a moment. Which process is endothermic? And you can always think of this as going in. Endo means going in, taking heat from the surroundings. All right, so freezing water. When water freezes, does it take in heat? Actually, when water freezes, it has to lose energy for those molecules to slow down, so it can't be freezing. When steam condenses, it's going to have to slow down. The molecules will have to slow down, so it can't be that. Evaporation. Those molecules of water that leave are taking heat away. So if they take heat away, this is an endothermic reaction. And we have to really say, with respect to the water, right? Water. So with respect to the water, it's losing heat. It's getting cooler. And sublimation of dry ice, would that take in heat? That might take in heat too. I think the best answer is right here. I think sublimation of dry ice might work. So that would have to take in heat to actually change from the solid to the gas. So you could probably say both of these are correct. Not a very good quiz question. Not asked very well up here and then down here. All right. If you do equilibrium stuff, this is where a lot of students have problems. This is a harder problem. This is probably one of the harder problems this evening. So I'll give you a moment to try to think about that. While you're doing that, if anyone has any idea why, usually we have a lot more folks here, and tonight not so many. Is there some reason you can think of? Curious, very curious. Your teacher hasn't taught you that yet, so you'll be ready when this comes up, THB. You'll be ready for this. This is called Le Chatelier's principle, It's interesting. These arrows here mean that some of these things are changing this way, but then they're breaking down and going back the other way. So if you think about it, yeah, THB, you might be right about that. It's always kind of like kind of a mystery to me of how YouTube does things. All right, so here's the key with this. We have 1 plus 3. We have 4. You could think of it as 4 moles here. And you could think of it as 2 moles of gas here. So which one's going to have more pressure? 4 moles of gas or 2 moles of gas? Yeah, so this side will have a lot more pressure. So if we start putting pressure here, we squeeze this, it's going to squeeze down and your equilibrium is going to shift to the right. So the answer is A, it's going to shift to the right because the 4 moles, they don't have much, they're getting pushed, they're getting compressed, and so they'll react to relieve that stress. That's how it's kind of stated. And when they react, form more of the ammonia here, and now they occupy less volume because it's just 2 moles of gas. Yeah, so Yeah, ice tables. Exactly, Gershom. Those are what we're talking about here. So when you're thinking about equilibrium, whatever relieves the pressure, that's the way the equilibrium will shift. So here, because we're getting fewer moles, when they react, goes to the right with more pressure. So kind of an interesting one. All right. The highest pH. At first, it looks kind of like an easy question. Maybe it is an easy question. Yeah, Madhurya, these are equilibrium questions are the hardest type of questions. They're one of the hardest things. That and redox reactions, I think, are the really, really tough things. All right, so highest pH. We do need to know what we're talking about, highest pH. Sometimes people see this and think, oh, pH is all about acids, so you choose the acid. But the highest pH, we have 1, we have 14. So here we get more of a base, and here we get more of an acid. So the highest pH is going to be a base. And there's only one base here. You can tell you have a metal and the hydroxide group. So yeah, it has to be B. And I really recommend, I tell my students, do I have it here? Yeah. I tell my students to really make sure they know the strong acids and the strong bases. It's kind of easy because these are all group 1. Sodium, potassium, lithium are all in group 1, and calcium, barium, strontium group 2. So I would definitely make sure you know these and most of these because it comes up a lot. So strong acids and strong bases, pretty good to remember. All right. We're kind of getting down here tonight. Here is my if you were with us at the beginning, my red cat on an ox. So see if you can use my little mnemonic here, and you have the chart on the wall. Excellent. Yeah, it's important to know. It comes up. It's one of those things when you're taking a test, you don't want to have to think too much about stuff you could just have in memory. So it's this idea of cognitive load. So if you can make it easier on yourself and you don't have to try to remember, if it just comes quickly, you just do better on the test. All right, so electrochemical cell, the anode, is the site of which of these? So Aryan, you're saying A. How does this relate to my AI generated image? I had to put the text in. AI can't do text very well. So you can think of reduction is at the cathode, and then, I'm sorry, cathode, right? Red cat. So reduction is at the cathode, right? And, wow, my brain is frying. Reduction's at the cathode, so oxidation right here is at the anode, anox. There we go. So we're saying anode, it's got to be oxidation. So make sure you practice with that if you have a mnemonic to help you along. CRP, cathode reduction positive. And no, it's not bad. It's not a bad way to remember it. I haven't seen that before. All right, we're going to do one more, and I think we're gonna wrap it up there. Oh, this is one of those dumb ones. Not dumb, but they put these on the test. It's almost a give me if you've done lab work for very, very much. So give it a try there. And THV, are you still there? Because if so, I'll give you a link to some balancing stuff that will help you. I actually have a short course on balancing on my channel. So if you're still there, let me know. All right, which piece of lab equipment is best used to measure the volume of a liquid precisely? What are you guys thinking? Volume precisely. So it's an interesting question because when I look at the question now, when I worked in a lab, I would often use graduated pipettes that could be very, very accurate. So I, as a teacher, would accept this here. Probably what I'm guessing is that the people who wrote this question are thinking it's a graduated cylinder because they didn't say a graduated pipette. It's not a great question here either, but you could argue pipette, but you'd probably want to say it would be graduated because there are non-graduated pipettes as well. Yeah, kind of an interesting question. That's all I have. I thought it would take longer to do that, but that's what I got. What kind of questions do you guys have for me? I might be able to find some resources here on my channel that can help you out here potentially. I'm going to give this here to THV. THV, if you go here, there's a course on balancing for you right there that you can use. I've only made one course on my YouTube channel. I don't really like the way they do it a whole lot, but I tried this one. It's okay if you need to be able to balance. I think there might be some types of reaction stuff there as well. Any questions for me? Now there's like more people than there have been, and I'm pretty much done with my stuff. So I am working on trying to build an app that has questions and answers and help and links to my videos. So hopefully that's coming along, but it's slow because I'm having to learn how to program, and it's really hard. So soon. Chiral compounds. I would say for chiral compounds, you really want to get models out, get yourself some molecular models and work through problems using the molecular models so you can really see the stereoisomerism that's going on, those enantiomers. That's the way I think is really best to learn it. It's hard to learn it from a book. Electrochemistry, I think you probably want to make sure you have redox down pretty well for electrochemistry. I have let me get this here, breslin.org. I have a big resource on redox. This year I really worked hard to get a bunch of videos on redox. It's mainly around balancing redox reactions, but yeah, let me drop the redox in here. So that's probably for electrochem. I'd make sure you can do the redox. That's kind of a good place to start. Hello, precious Osakwe. What else are we asking? Yeah, SN1 and SN2, I've not done much with that. I'd kind of like to because it's one of those things you want to try to visualize. If you have access to models like this, you know, try to almost work it out like a chemistry puppet show, and that somehow the physical and actually setting it up to do that really helps you remember. JEE, yeah, JE is not as tough as NEAT, but it's tough. Pawan Gaming, you don't think time exists? I might agree with you. Yeah, the lion says grr. There's another one that's oil rig, but I think the lion's a little more carbon neutral, so I like the lion. All right. All right. No more questions for me. We are in a simulation. That yeah, I've heard that. I mean, you know, you can. It's a philosophical statement. You start with some kind of statements and build, and you know, you might end up there. But in reality, does it matter? I mean, can you change the simulation, Pawan? Do you have any power to change that simulation? So just enjoy it. All right. Yeah, THB, you were asking about types of reactions. I don't know if I have that video right here available. Actually, let me copy this into here. This is the, I was just talking about the application I'm building. So if you go here, this is what I'm starting to build, and you can give me feedback on it. Yeah, take a look at that. More questions, drop more questions. Yeah, if you're on my community tab, I drop a question every day. It has an answer, and often it has a video, so check that out. How can I tell whether a compound is polar or non-polar? I have a video for that somewhere. Let me go to my channel, and I'll put my channel up here. Instead of looking at my big head, you can, let's go to polar, and I can show all of them. This is where all my videos live on my channel. Views, there it is. I can go here and copy it, and like magic, you now have a video on polar, non-polar. Yeah. So electronegativity, Cl and F. Fluorine is the most electronegative element on the periodic table. And if you remember that, you can tell what the electronegativity on all of the other ones are. So let me see if I can find where we were. Here. Yeah. So if you know that fluorine is the most electronegative, any direction you go, we don't really think about the noble gases. Any direction you go from fluorine, it's going to decrease. So I always just remember fluorine's the most, and then I'm good. I don't have to remember much else, which is nice. Playlists on naming hydrocarbons. Yeah, actually, John, if you go to my channel, let's go back to my channel, and we can just go to YouTube. You could just go to YouTube, and if you search on, now you guys will see everything I watch that comes up here. If you just search on Dr. B, methyl, let's see if that works. Does anything come up? No, it doesn't. If you search on a compound you want to name, like 2-methyl, this may not work. METH, I can do it, THYL, butane. Like, click the first one that comes up. My videos all come up, so that's my video there. So any compound you type in, any common compound, you'll see how to write the structure, and then it shows us as an ad, of course. So then I go through and show you how to do the naming and all that. So yeah, you can just search for that. AC circuit, that's physics stuff. I don't know if I can really stand up against all the physics folks out there. Oh, thanks, Dees. That's nice. I appreciate that. CH3Cl has more electronegativity than CH3F. I'd have to look at that. That may have to do with the size of the halogen on there. That kind of can play into it a little bit. All right. Well, I think that's probably going to be it for me this evening. Hopefully next week I'll put the thumbnail with the right date so I don't confuse people. And we'll do some more stuff. So Kim, HF is not considered a strong acid for a number of reasons. The strongest, though, that would take a bit of time. You have to look at the Ka and some other things like that to really look at that. So I would say look up Ka and acid, and that should set you straight on that. So all right, I'm going to actually, it's right here. It's 9:04 in the evening, and I got to get up early, so I think I'm going to start heading towards bed. Everybody have a great evening, or if you're on the other side of the world, have a great morning. Check out on my channel, if you go to look for Dr. Breslin, Dr. B, any of my videos. If you go to the community tab, every day I'm posting a quiz question. So just something fun to do. All right, everybody, have a great evening. This is Dr. B. Thanks for watching.